Thanks everybody for attending today. I guess it could be the morning, night, since there is people from all over the world. Yeah, so thanks for taking a time to watch my talk. Um, so today I am going to be talking about build times, how we brought down our build times. This is a series of two talks, and this is the first part, general optimization tips. It's a journey on Pinterest build speed improvement path. My name is Manuel Nakamurakare, and as you can tell, I work at Pinterest. You can reach out to me via this Twitter handle and via this email in case you have any questions. Before we start, I wanted to share the agenda for today. Um, so I'll start telling the journey of Pinterest build times, what we used to have before we started working on improvements, what we have today, which were our main areas of investigation. And we have three categories for this: parallelization, cache, dev experience. Lastly, we'll see the results from the optimization tips that we'll be talking about today. What's next? So I'll be giving some intro to my future talk, and then lastly a QA. But first, I wanted to share some about my company. As I said before, I work for Pinterest. Our mission is to bring everyone to the inspiration to create a life that they love. We have more than 400 million global monthly active users, more than 3 billion pins saved, and more than 3,000 employees. We have engineering offices in San Francisco, Seattle, Mexico City, and Toronto. So what will you learn today? So today I will be sharing how we debug using some tools in order to understand the Android build speed, and how to look for issues, what kind of areas of investigations there are, and tips that you can use in order to speed up your builds. So there will be different tips that you can try on your own and see if that works for you. So let's start with this. So as the first part of the talk, I'll be going through the Pinterest build times journey. So what we had before? What we had before we started working on improvements. So we used to get these kind of Slack messages. People were kind of not, I wouldn't say mad, but they were frustrated with the build times. Some people were seeing build times of up to 20 minutes. So of course, people were frustrated. Managers were wondering if something was wrong, right? Because how come the build time be so slow? So this is data that we have from December 2020. At that time, our P50. So P50 means what most people or the average people is getting for build times, which was 1 minute and 25 seconds. So that doesn't seem too bad. But then our P95, it's a number that measures uh, the worst build times. So for that, we had 11 minutes and 5 seconds. So that means that some people were making some changes in the app, and they were getting these kind of build times. At that time, we were still not very modularized. We only had 25 modules in total, but there was one that was really big. Most of the app code was living there, most of the feature code, which meant that anytime that person was developing a new feature or something like that, they were getting they could get bad build times. So where we are today. So today people are very happy. Now people are saying that they are able to use their M1 laptops. They can clone the repo and build the app in just 5 minutes. So now people are very happy. Uh, these are our current build times. This was measured in the third week of March this year. So now our P50 is just 32 seconds. So it's 62% better. Our P95 is 7 minutes and 36 seconds, or 31% better. Now we are in a much more modularized code base. We have 100 plus modules and counting, because every week we add more and more. But we still have one big module, so we still have room for improvement. And how did we get there? Well, we just started giving laptops to everybody. Yeah, that was the trick. Just give M1 laptops, and that was it. So that's all. I mean, there's nothing else. There's nothing else to do. Well, I'm just kidding. I mean, but really, switching to M1 laptops was game changer. It really helped a lot. Uh, but it's also worth noting, right, that at one point, M1 laptops are not going to be fast enough, and also not everyone can afford M1 laptops. And also, in this case, I'm going to be talking about what we did before there were M1 laptops. So I think it's still relevant to get to know tips to improve builds. Um, Next, I'm going to be talking about our main areas of investigations and things that we found. So again, to reiterate, this was all of what I am going to be talking about today was before M1 laptops were widely available, and when we in Pinterest still had a highly monolithic app, so we had some opportunities because of that. Uh, Before I start talking about how we debug and how we understood the issues, I wanted to just give a quick intro on Gradle Enterprise. So Gradle Enterprise is a tool that allows you to understand build times. It has many capabilities. It allows you to to push your build scans to a server, and then you're able to see um, why your build is slow, what kind of module is slowing down things, what kind of task is doing that. So in here, I want to show just some quick examples of the things that you can do in Gradle Enterprise. So in this case, in this slide that I'm showing, you can see the build time, the average, which is 1 minute and 34 seconds in this case. You can see different metrics like P50, P95, and things like that. In this case, in this slide, I'm showing a specific build scan that somebody did. In this case, you can see all the tasks that were executed. Uh, some of them are coming from cache. When you see from cache, that means that it's coming from cache. You can see that some of them are up to date. That means that it's coming from the incremental build cache. You can see also the timeline. Um, you can also see some statistics in this tab. For example, you can see the percentage of tasks that were avoided because it's coming from cache, or because it's coming from incremental cache. The tasks that were cacheable, non-cacheable. So as you can see, Gradle Enterprise can give you a lot of data. In this case, we are comparing one build done in CI versus one build done locally. In this case, we were expecting, because in CI, we have a remote cache, which CI is able to take advantage of, and we wanted to compare the build that was done on CI versus local build and see if they had differences. So in this case, Great Enterprise will allow you to detect differences that you have in tasks, so that you can debug if there is something wrong, which is the reason why maybe you are having lots of cache misses. So now that I gave a quick intro to Great Enterprise, I want to start talking about our areas of investigation. So the first one is parallelization. Um, in this graph, we are seeing again a build scan on Great Enterprise. Now we see here in the top part of the slide, there is a timeline. So the x axis is the time, and the y-axis is the threads. So in this case, you can see at the beginning that there are many tasks that are getting executed at the beginning, but then as the time goes on, you can see that, for example, base compilation is happening mostly by itself. Then after that, there is some parallelization, but not a lot. Then this Pinterest task, Pinterest cap generate stops is getting executed by itself mostly until pretty much the end. So we are here wasting a lot of uh, CPU, a lot of thread capacity. Sorry. Um, and you can see here, right, that how long the Pinterest tasks are taking. In this case, you can see that it's almost like 5 minutes, and the total build time for this build was 7 minutes and a half, which means that the Pinterest module is taking about 5 minutes and a half to execute. So it's taking most of the build, and it's because we don't have a lot of parallelization here. So when we started investigating why our build times were slow, this was one of the first opportunities just to start working on modularization. Uh, as soon as we started working on this, we started seeing some very early wins. In this case, you can see a chat where two engineers are discussing and they think it's a bug because things are compiling too fast. But the reality is that engineer one is working on a module that has been modularized and now it's very fast. So they are just surprised. The truth is that modularization was a really good opportunity. It's just that it's an effort that takes a really long time. In fact, we started doing this work in early 2020 and we are still modularizing. So it's just something that takes a lot of time. Um, and there are also some gotchas that I will share on a future talk when I discuss optimizations in a modularized world. These are a couple of flags that are relevant in case you can start parallelizing. So the first one allows you to parallelize the compilation of Gradle of modules, and then the second one allows you to parallelize capped task execution. The next area of investigation for us was cache. So in when we are developing in Android, we have three types of cache available for this purpose. The first one is the incremental cache. So the incremental cache is that cache that anytime you make any changes in your code, this type of cache should only recompile the files that you changed plus anything that depending on it. This one lives in the build folder of each module. And how can you test it? So the first step is to make sure that you disable your local and the remote cache. So in order to do that, you use this flag, the no build cache. And then you can do a clean build. So as I say in this step one, Gradle, clean, build debug, and no build cache. So that way, you are going to be clearing your incremental cache. You are making sure that you don't use the remote or the local cache, and you are going to be filling up your incremental cache. Then in step two, you do this, so you don't pass the clean task anymore because now you don't want to clean the incremental cache again, and you keep passing the no build cache flag so that you don't use the local or the remote cache. So in this case, you're making sure that you are building the app, but you are reusing the incremental cache. So you can see in this case, the build took only 15 seconds versus the one before that took 17 minutes. In the step one, also another thing worth pointing out is that if you see in tasks that were avoided because of the incremental cache, which is the up-to-date one, almost 0% of tasks were avoided. but now you see that this number increased a lot. So that means that in this case, the incremental cache is working. Uh, what are some things that we did to optimize incremental cache? So we found that there were some bugs that were preventing us from fully utilizing the incremental cache. This is one example. Incremental cache doesn't work with Java modules and Kotlin modules without any Kotlin classes. So thankfully, there was an easy solution. We just added a Kotlin class to Java only modules, and we measured this. So when we were testing, we tested doing non-ABI changes, and we saw that even adding comments was causing long build times. So before we added this Kotlin file to the Java only modules, these incremental changes were taking 574 seconds. And after this change, we found that it was only taking 128 seconds. So that's like 4 times the improvement. It's 4 times better. Um, there were also some other unexpected cases where incremental cache was breaking. We found that some of the annotation processors that were generating code resulted in the non-deterministic order. So this was also causing incremental cache to not work very well. We found that any changes that result in a change in the R class, such as, for example, adding or removing resources, was also causing the incremental cache to break. But for this, you can currently use this flag, the Android non-transitive R class, and set it to true. So that way you can avoid that. Next type of cache is the local cache. So the local cache is basically the one that allows you to reuse Gradle task results when the same inputs are detected. So this type of cache works mostly at the Gradle module level. And this is how you can go about testing it. So as a first step, you can clear the local cache, which usually lives in this folder, the Gradle caches build cache one folder. That's the default folder. Then once you clear it, you want to make sure to fill it up using the local cache. So for that, first make sure that you disable the remote cache in case you have it enabled. And then you can just execute this command, Gradle clean build debug. So with that, you're filling up your local cache. And the last step is to clear the incremental cache and use the local cache. So now we are adding the clean, well, we are still using the clean task again, so that we make sure that we are not using the incremental cache. And in this way, we can test if the local cache is being used. Um, Now I want to talk about some of the things that we did in order to optimize the local cache. So pre-optimization, this is what we had. So still using Gradle Enterprise as a tool to debug build scans. The first time that we tested our local cache, so meaning after we fill it up and then we executed the build again, we were getting build times of 7 minutes, which was very long for what we were expecting, right? Since the local cache is already filled up, and we should be able to take advantage of it. So after we did this, we went to the timeline view of the scan, and we found that all of these tasks were getting executed. So as you can see, all of them are cap related, which is what made us realize that maybe using this flag, the use build cache for capped, could help. So we set it to true. And after that, this is what we got. So after we switched that flag, we tested the local build cache again, and now the build times when using local cache were much better. Instead of 10 minutes, now we were getting under 50 seconds. So that was a big difference. And in this case, you can see in the timeline that now nothing, well, in this case, we're using a filter that shows the cacheable tasks that are getting executed. And we see that there is no task. So this means that everything that is cacheable is coming from cache, and nothing of the cacheable tasks are getting executed, which is what is expected for this kind of cache. And these were the results of the optimizations. So pre-optimization, we were having 7 minutes and 16 seconds for build times when using the local cache. And after we flipped the flag, we were getting 50 seconds. So this flag helped us to make our build times 9 times faster. The next type of cache that I want to talk about is the remote cache. So the remote cache is very similar to the local cache. It works at the Gradle module level, but this cache is written in a remote server by CI usually, and is read only by local builds. So just to reiterate, the remote cache doesn't live in your local machine, but it lives in a remote server where usually only CI is able to write to it, and then developers only read from it. Oh, and another thing worth pointing out is that Gradle Enterprise, in addition to providing build scans, also provides a remote cache. So it's also helpful to have it because of that. So now, in order to test remote cache, there are two steps that you can take. So the first one is you want to make sure to clear your local cache. That way you are removing anything coming from the cache in case you use the remote cache before. And then in the second step, you execute the build, and again, you pass the clean task so that you make sure that you are not using the incremental cache, but the remote cache. So when we started testing the remote cache, we found that we had many issues that were preventing us from fully taking advantage of it. One example is we were using values in the code base that depended on the environment. And what do we mean by that? So we'll see next. In this case, in this slide, I'm showing a comparison between a build done on CI versus a build done locally. And we just wanted to compare why we are having too many cache misses, right? And in this case, we found that the difference was that on the build B, the one that is done remotely, had differences in this file, the build config file, compared to the build A, the local build. So we started investigating, and this is what we found. We found that in this build config property, we were setting the flag is CI to true when it was in CI, which makes sense. But the problem of this kind of setting this kind of value is that this depends on the environment, right? As I said before. So whenever you execute it locally, it's going to be false, and when it's executed remotely, it's going to be true. Similarly, for this other configuration, um, similarly, we were setting the value of suppress warnings based on the environment. Other things that were also preventing us from fully taking advantage of the remote cache was that we had some big assets that were failing to download given their size. So every time that you want to use the remote cache, right, if Gradle detects that your inputs are the same, then the outputs should be reusable. But sometimes these outputs, these are the artifacts are too big, so we were having issues because of that. Um, and we had to make some changes in our network in order to support these big artifacts. We found that having empty folders also causes issues. This happened a lot while we were modularizing, because a few times we decided to change our naming conventions or fix our names. So this caused CI to still keep those folders that were not used anymore, and this was causing remote cache misses. Another issue that we had was that remote cache entries were getting evicted too fast. And this happened because of two things. One was that we had enabled remote cache writes for every CI task, and we have a lot of CI pipelines. So this was one factor. The second factor was that we had some guided tasks that were storing big artifacts, and then also um, um, oh yeah, our remote cache lives in a server, but this server was had some limitations in storage, so we had to increase the storage size in order to be able to increase the cache capacity. Um, Sorry. Oh yeah. So this one shows, yeah. So in this view, we can see a comparison again between a build done remotely versus a build done locally. And in this case, the comparison tool from Gradle is telling us that then a folder is only declared in build A but not in build B. That's why we were getting some cache misses due to these task differences. One thing that really helped a lot in this case was to use this plugin, the Android Cache Fix Gradle plugin. It helped it has some workarounds, some Gradle issues like the empty folder ones, for example, and that help us to avoid cache misses. So after doing all of this analysis, we found that initially with using this tool, 66 tasks were different, meaning that they had the same inputs, but their outputs uh, were different for some reason. And after doing all that, after fixing all the things that we just talked about, like the empty folder situation or adding the plugin, we ended up with only one task that was different. And by reducing the number of tasks that were different, we were able to increase the efficiency of the remote cache use. And these were the results. Whenever people were building the master branch, it resulted in 2 to 3 minutes versus 10 minutes, which used to happen before the optimization. And 60%, we had a master branch hit success of 60% versus 0%. This means that 60% of the time when people were building a master branch, uh, they were they were fully utilizing the remote cache versus 0% that used to happen before. And the reason why this is 60% and not 100% is that sometimes people were building a master branch, but they were making some changes to their code. So in that sense, because they made some changes, they are not able to take full advantage of the remote cache. And that's it for remote cache. The next area of investigation that we had was dev experience. Um, One thing that we have in our setup is we have a recommended setting for development. Uh, so this type of setting was not the default before. It's a flavor that has a few languages, removes unnecessary plugins, disables unnecessary flavors, uses a higher mean SDK and doesn't use ProGuard, we found that after doing all of this, we were able to reduce the configuration time and the execution time significantly. That's why we hide all of these when using a flavor special for development. But the thing uh, that we had before was that this was not the default setting for developers. So developers had to, as they get onboarded into the Android setup, they had to set it up uh, by themselves. So after this, after we realized that some people were not doing that, um, we just made this the default, and these are the results of what we saw. So we saw that sometimes people uh, were not using the recommended development settings completely, and in those cases, they had build times of 45 minutes or plus, versus just having 9.5 minutes whenever they were using the recommended flavor fast dev. Yeah, so one thing that is worth noting is that we use flavors in order to set the development setup. So all of these things are specific to a flavor which we call fast dev. So whenever people were combining flavors, like for example using one fast dev for one module, but using um, the dev or the production flavor, and that's when they were getting very very bad build times. We also explored remote builds. However, at that time, back in 2020, early 2020, we didn't find very compelling reasons to do this. The reason is that we did some initial tests and we didn't find a lot of build time gains. And we realized that if we wanted to go through this route, then we would have to be investing in maintaining this properly. So it didn't seem worth the investment for us at that time, since we had to choose very wisely where we wanted to do the optimizations. Um, and what did we achieve with all the optimizations that we discussed today? So remember again, we are talking about a time when we didn't have N1 machines, and we had a very big module. So before we optimized, as I shared before at the beginning, our P50, the kind of build times that the average developer will get is 1 minute and 25 seconds. The P95 was 11 minutes and 5 seconds. Post optimizations. Uh, sorry, I got this. Yeah, yeah. Post optimizations. The P50 were 1 minute and 2 seconds. So we were able to improve this by 27%. And then the P95s were improved to 9 minutes and 4 seconds. So 18% better. Even though these numbers didn't seem, um, even though the numbers are not like are not very impressive, we found very big improvements in some specific scenarios. So, for example, when doing clean builds from a local environment, we went to 50 seconds from 7 minutes. So it's about 9 times faster. And whenever we were doing clean builds from the remote cache, um, we were able to achieve build times of 3 minutes, which is 3 times faster. And what's next? So, in terms of the optimizations that we saw, what is next is just to modularize and then try to be also mindful about the how we modularized. Uh, that this is going to be my future talk. I'm going to talk about optimizations in a modularized world. One big hint is to avoid recompiling unnecessarily, because even though you modularize and you are building a lot of things in parallel, building unnecessarily can really slow things down. And and also I wanna in my future talk I would like to share more about metrics that we found useful, because in the past we used to only look at the build times in the flavors that usually developers use. But we found that this doesn't really give you the whole picture. We need to have some secondary metrics in order to understand better where we are having some potential regressions. So that's all. I wanted to share that Pinterest is hiring. So here is a link where you can apply. You can also write an email to this email if you're interested. You can use this QR code for a position that my team is hiring. Right now, we are hiring for Android build engineers. So if you enjoyed the content that you saw in this talk and you're excited about working on these type of problems, feel free to ping me or apply via the QR code. And now I would like to open it to Q&A.
All right. Not sure why my webcam isn't showing up. That's terrific. Well, everyone can hear me. So thank you so much, Manuel, for that great talk. And I just want to give a quick reminder to everyone that we will be posting these talks on the YouTube channel. I know there's a lot of very useful and specific little Gradle tweaks and stuff like that in Manuel's talk. So I know for myself, I'll be reviewing those on the YouTube channel later. So thank you so much. So yeah, we'll just wait a moment for the questions to pile in. Just a thought, Manuel. One thing that I thought could be kind of an interesting perspective is for me, optimizing Gradle build times is like this thing which just makes me personally happier as an individual. But at a company at the size of like Pinterest, I guess you could almost be like attaching a dollar value to the amount of time saved
Yep.
for your employees. So
Yep. Yeah, so yeah, definitely, and I think it's really interesting that you talk about that because that's in fact how we convinced management to get us M1 laptops. I don't remember the exact numbers. Oh yeah, I think this is coming to my mind, but I think we measured the build times that we had before M1 laptops and after M1 laptops, and and just for some context, we have between 60 and 80 Android developers. And because of the improvements, it's like we got 3 engineers back because of the time savings. And that more than paid back the investment that we got in M1 laptops and all the optimizations that we did.
that's awesome. Like that's how you really convince management. All right. So I think looks like that's all of the questions we've got here. So go ahead and if you want to start reading one, I can get it to pop up on the stage there, Manuel.
All right. Yeah, let's get through the questions. Yeah, I think this question, would you advise using a multimodal approach on a smaller application, or does it depend on the project size and other factors? Yeah, I don't think that there is right or wrong. This is why I think engineering or software engineering is interesting. I would say that maybe if your app is not big enough, maybe creating one module or trying to modularize it might be more work than it's worth. However, what I would say is that instead of modularizing, perhaps you can grow your app in a more organized way. Instead of creating modules, you could create packages, different packages for things that should be modules in the future. So that way, in the future, when you need to create, or when you are in your code size is bigger, you can create modules for them and it should be much easier.
Okay, great. I'll just pull up the other one here. I am back.
You're back. How many modules and lines of code does Pinterest have? Uh, that's a good question. Let me see if I can get some numbers. I think I. So for modules, I think right now we have more than 100. Uh, but for lines of code, I don't remember very well. I think it was in the order of magnitude of millions, maybe 1 or 2 millions. Can't remember very well.
That's quite a code base. All right, looks like that is it for the questions. So once again, I'd just like to thank Manuel for the great talk here, and yeah, of course, do consider checking out the YouTube channel later on to check the talk out again and get the finer details. And yeah, that's basically it. So just a quick reminder, we have 2 more talks for the rest of what is for me the evening, for some of you probably morning. And our next talk, which will be taking place at 9 p.m. Eastern Time, will be on modeling retrofit responses with sealed classes and coroutines. So any final words there, Manuel?
No, so just thanks, Andrew Worldwide. Thanks, Ryan, for hosting me. I hope people enjoy my talk, or if you didn't have the chance to watch me right now, you can at least watch me on YouTube. Hopefully, I hope the content is interesting for people and they are able to take advantage of some of the tips that were useful for us.
Very much so. Thank you so much, Manuel. All right, that'll be it for this session, and I'll see some of you in the chat rooms.
All right, thank you very much. Bye.